So this is the 2016 Junior Cert Higher Level Paper 1 and we're looking at question number 14. The function h of x below gives the approximate height of the water at Hoth Harbour on a particular day from 12 noon to 5 p.m. So here's our function h of x, where h of x is the height of the water in centimetres and x is the time in hours after 12 noon. Part A says draw the graph of the function h of x on the axes below for x between 0 and 5 and x is an element of the set of real numbers. So remember we have our function h of x is 10x squared minus 50x plus 130. So there's our function. And we have to plot the curve on here. So what I'm going to do then is I'm going to change my x values here for all these values individually. So these x values here, I'm going to change them for all of these values along here. I'm going to find my corresponding y value, or my h of x value. So let's have a look. H of 0 is 10 by 0 squared minus 50 by 0 plus 130. So I've just replaced the x with 0 everywhere. And that gives me a value of 130. So you can do this in your calculator if you want. So the first point is 0, 130, which is here. Okay, next I'm going to do h of 1, which is 10 by 1 squared minus 50 by 1 plus 130. So again, you can do this on your calculator or in your head. So this is 10 by 1 squared is 10 minus 50, which is minus 40, plus 130, which is 90. So when x is 1, y or h of 1 is 90. So I'm going to there. Okay, next h of 2. That is 10 bracket 2 squared minus 50 times 2 plus 130. So 2 squared is 4, 10 fours is 40. So 40 minus 100 is minus 60. And minus 60 plus 130 is 70. So it's going to be at 2, we're going to go up to 70. From 2, go up to 70. Okay, h of 3 is 10 by 3 squared minus 50 times 3 plus 130. So 3 squared is 9, 10 nines is 90. 90 minus 150 is minus 60. And minus 60 plus 130 is 70 again. So when x is 3, y is 70. And h of 4 is 10 by 4 squared minus 50 by 4 plus 130. By the way, you can do all of this on the table calculator on your function, the table function on your calculator if you prefer. That's certainly allowed and would be a little bit quicker than this, but this is a good exercise for revision anyway. So 10 by 4 squared is 16, 10 16s is 160, minus 200, that's minus 40, plus 130 is 90. We can see the symmetry of the curve appearing now, so over to 4, up to 90. So you can nearly predict that the next one will be up here, but let's just double check. h of 5, 10 by 5 squared minus 50 by 5 plus 130. So 5 squared is 25 by 10 is 250 minus 250 is 0 plus 130. And there we go, it does give us the symmetry. So that's our points plotted, and now all we need to do is, as per the question, draw the graph. So we're going to join these points with a smooth quadratic curve or a smooth parabola, as smooth as possible. Something like that. So you'll be able to draw something a bit better than this. I'm just going to fix the middle here. There we go. Okay, so that's my quadratic, which isn't so smooth, but should be smoother for you. And now I'm going to move on to the next part. B. Use your graph in part A to answer the following questions. Part 1, find the height of the water at noon. Okay, so let's go back. Now they said the x-axis is the time, x is the time in hours after noon. So if it's at noon, x would be 0. So we can see there, at 0 we go up and the height is 130 centimeters. So 13 centimeters is the height at noon. Estimate the height of the water at its lowest point. So the height of the water at its lowest point will be right here in the middle. So from there you're going to drop a line at its lowest point, from there across, bring a line across, so you're looking at something like 64 centimeters, something in that region. So this would be 70, so a little bit lower than that. So we'll say 64 centimeters. So long as this is correct according to your graph, then that'll be fine. Part 3, after 12 noon, how long did it take before the water was at its lowest point? So that would be on the same graph, and from that same point, this time you're going to go down. You can see the time would be right between 2 and 3, so 2.5, so it's going to be 2.5 hours after noon, so it's going to be after 12, how long did it take? So 2.5 hours will be the answer. Okay. Part C. The graph on the right shows the approximate height of the water in centimeters at Crookhaven on a different day, from 12 noon to 6 p.m. The graph is symmetrical. On this day, the height of the water at 12 noon was 180 centimeters, and the height of the water at the lowest point on the graph was 0 centimeters. So there's the lowest point. There's 12 noon. Taking x as the time in hours after 12 noon, this graph is given by the function g of x is equal to ax squared plus bx plus c, where a, b and c are elements of the z set, so they are integers, and x is an element of the real set. So the first thing we're asked is to find the value of c. Okay, well, the value of c would be the y-intercept. Okay, so the value of c, or if you want to, you can see immediately that's 180. Okay, or what you can do is you can say, well, I know this point, right? So if you know the coordinates of this point are 0, 180. So when I plug 0 in for x, I should get out 180. Okay, so if I do that here, the g of 0 will be equal to a by 0 squared plus b by 0 plus c, and I know that's equal to 180, because when I put in 0 I should get out 180, because that's a point on the line, that's an x, y coordinate on the line. So a by 0 squared is 0, b by 0 is 0, and I'm left just with c is 180. So that's the value of c. Part 2 then says, hence or otherwise find the value of a and the value of b. Okay, well, At the moment now, I know that my g of x is actually a x squared plus bx plus 180, because I now know that c is 180. So this is my g of x now as it stands, g of x. So if I want to figure out what a and b are, I'm going to have to figure out some more points on this curve. Okay, well I know this point here this is a point on the curve, and this point here is the point if it's symmetrical, like it said in the question. It did say the graph is symmetrical, so that means here the lowest point would be halfway between 0 and 6, so that's 3 there. So this point, the coordinate of this point would be 3, 0. So I can plug this coordinate 3, 0 in for x and y. Or in other words, if I put 3 in, I should get an answer of 0. So if I put 3 into the g of x, so I say g of 3 is equal to a by 3 squared plus b by 3 plus 180, and I know that that is equal to 0. Because when you put 3 in, you get out a y value of 0, or a g of x value of 0. So, when I tidy this up, that gives me 3 squared is 9, so that leaves me with 9a plus b by 3 is 3b, and plus 180 equals 0. So that's one equation with two unknowns. So I'm going to use another point now to give me another equation in a and b, and then I'm going to solve them simultaneously. So do I know any other points on this curve? Well, I do. I know this point here. And that point there is the point 6, 180. So when I plug 6 into the function, I should get out 180. So let's have a look. G of 6 is equal to a by 6 squared plus b by 6 plus 180, and I know that's equal to 180. So what does that give me? Well, 6 squared is 36, so that's 36a, plus b by 6 is 6b, plus 180 equals 180. And I can subtract 180 from both sides. That gives me 36a plus 6b equals 0. Okay, so now I'm going to use this equation here and this equation here. I'm going to bring these two together and solve simultaneously. So that's going to be, I'll just bring this 180 over, so it's going to give me, and in fact I'm going to divide everything here by 3 to make it a bit simpler. So I'll give me 3a plus b plus 60 equals 0. I'm going to divide everything here by 6, so that'll give me 6a plus b equals 0. Okay, now I'm going to bring this 60 over the other side, make it a negative, and I'm going to put this new version of the equation underneath. So I've got 3a plus b equals negative 60. And now I can start to solve simultaneously. So I'm going to use the elimination method. I've got b here and b here, so I can subtract to eliminate them. So I have 6a minus 3a is 3a. b minus b is 0. And 0 minus 60 on the calculator, that gives me positive 60 or 60. So 3a is 60, and if I divide both sides by 3, these 3's cancel, and I'm left with a is equal to 20. So that's my A value done and boxed off. And now I'm going to substitute that back into maybe this equation here. So, I know, I'll pick an easier one. 6, this one. So I'll write this again. 6A plus B is 0. I'm going to sub in the 20 for the A, so 620 plus B is 0. 6 by 20 is 120 plus B is 0. So now I just bring the 120 over. That becomes a negative, and I have B is negative 120. Box that answer off. And that is my value of A and my value of B. Here and here. And that's the end of the question.